Hi everyone, welcome along again. This is lecture 17 of the Alphacam side of our Advanced Manufacturing Technology module. And today we're going to talk about a few things. We're going to first look at screen to machine, the process of taking your digitally prepared Alphacam files and actually sending them to a physical machine to have them physically prepared. And then I want to talk to you about the assessment for the Alphacam portion of the module. I'm going to run through a previous example and just give you an idea of what sort of stuff will be asked and what sort of a standard you need to get to for this module. So first of all, just to go through an overview of screen to machine, we've already covered the preparation of geometry and applying tooling. The next step then was obviously to run the simulation digitally to make sure that digitally you're not going to either destroy the machine or the workpiece. And what we want to pick up today is this, the output of the actual coding from Alphacam that the machine can follow. So it's the NC code. And to do that and to check and edit and make any changes to that NC code, we're going to use a version of Alphacam, a kind of a plugin called Alpha Edit. And then we'll be in a position to have it sent to the machine and have it process the physical workpiece for us. Now moving over to Alphacam, we can see here's a file that we've worked on previously, and we've drawn all the geometry necessary to make the few components of the stool, and we've applied the tooling. We've also put this grey block on to represent the piece of material, the actual piece of timber that we load up onto the bed of the CNC in a while. And the next logical thing to do digitally would be to go to View, Solid Simulation, and press Play, just to make sure that the machine's okay here. And that's the first verification that the tooling is correct. I'll speed that right the way up. And when you're happy that it looks okay there, you're now in a position to actually send this program to the CNC to have it physically process it. So I'll turn off the solid simulation. And it's similar in a lot of ways to just printing a document or 3D printing a document, but you're not sending it to the printer, you're actually outputting NC code. And as many of you may know already, NC code stands for numeric control code. And because nowadays we generate and edit a lot of that code using computers, CNC is the common abbreviation, Computer Numeric Control Code. And to generate something like this, we need this type of code, or G code, to tell the computer, to tell the CNC where to move the cutter and at what speed and what time, what position it needs to start and stop at. So the coding is almost like HTML code, the coding that is used to make websites, but the computer needs to read this coding and then it'll translate that for the computer-guided cutter and tell it where to go and what positions. So we're now pretty happy with the machining that we've applied to this and we're ready to actually manufacture it. So in this case, you would go to Home, and there's a few options here that may very well be grayed out in your student versions of the software. In order to prepare this video, I had to borrow and transfer a license to my machine so I could actually list and output and generate NC code. That's one of the limitations of the training version of Alphacam. You do not have the ability to generate or output NC code. So if you want to do that and actually generate NC code, you'll have to use one of the fully licensed machines in the computer labs. So let's go to Select Post if you haven't already, which will allow you to select the machine you're after. I'm just going to use the standard 3-axis Alphacam built-in machine. That's like selecting your printer. And then we can go and output NC code, because I actually want to save it to a disk. Or you could just list NC code, which is the same thing, it just doesn't allow you to save it. It just shows you the NC code. So if I go output NC code, it's going to confirm which printer, essentially, or which router, which post processor I want to send it to. So I'm happy enough with that one. And it's going to ask me if I want to output it to file or machine or both. Now in this instance, my computer here is not hardwired or hooked up or networked to a machine, so I'm going to have to send it to file. But it's not going to throw up an error. I'm just going to pick both. If my laptop were to be hooked up or hardwired to the physical CNC machine itself, I could just print directly to the machine. So I'm going to select both for now and press OK, and it will show up. First of all, it's going to prompt me where to save it, so I'm just going to put in a different file name there. I'll save it to my desktop for now. It opens up and lists the NC code. I'm just going to press OK on that, and when it runs through all that NC code, it'll throw up another program called Alpha Edit. And this is where you can go to actually double check your coding, to check how long it's going to take. I'm not going to start the job. If I just press start, it'll send it to the machine. So I'm going to cancel that for a minute. Here you can actually see all the NC coding. Now operation we're after completing there has a lot of complexity to it. There's a lot of machining going on. So you can see it's a lot more complicated. There's a lot more lines of the G code than there was in that smiley face example a second ago. Here you can see the timing for each individual operation. So if I pick operation 6, for example, you can see operation 6 is going to only be a 36-second operation, and the total time of this whole stool when processed on the machine I picked will be just over half an hour. And as I move through all the different G codes, as you get more experienced with it, really what you can look for is the X and Y values, so, and also the Z values. So anywhere you have a minus in the Z value, you know it's going to potentially be a problem because it could go down beneath the bed of the CNC. So if you're fully up to speed in the manipulation and generation of G code, you can get in here and retype and change it. But one of the advantages and the main uses of Alphacam is so you don't have to be an expert in coding or G coding. Alphacam will make and generate this coding for you. So if you're happy with that, and if you have already pressed cancel and got rid of that button, you can go to comms and you can go output, and you can actually select the machine that you're going to output to it and simply press start. Now it throws up an error in my case because I'm not hardwired to a machine, but you can also save that coding and bring it on a USB stick to the machine or to the computer hooked up to the machine. Now that we're happy that we've generated the NC code we're after, we're going to move to the machine. And this is the machine we're probably familiar with. You can see that brown surface there is the bed of the machine, and all the cutters, the number of heads that control all the different cutters, are cased within this kind of white block at the back there. You can see here there's a yellow warning, notification showing that the Z is up and down, and in this image you can see that the X is left and right in this case, and front to back there is the Y. So we're not going to cover the actual changing of tools and the setting up of tools in this because that will be different and unique to every individual machine, but that will always take place here at the control panel. This control panel in this case is also where job 1, the job we've just sent to the machine, will also arrive. And if you're confident that everything is set up correctly, you're ready to go, you just press execute or press the green button and it'll start processing the component that you've just created the NC code for in Alphacam. These are pods, and I suppose first of all we better talk about the bed of the CNC. This is a kind of a plasticky resin bed. It's designed to be softer than the cutters itself, and if you look at it carefully you'll see various nicks and grooves over the years. It's probably been just worn and torn over the years. You can actually replace that, so you can see those Allen key, the hex head bolts there around the bed. You just simply remove those and you can buy and replace a new bed. So all of those holes, they're there to allow the suction. If I just go back for a second to the previous slide, there's a little button there, and that is the control for a very strong compressor. When you press the green button there, the compressor is turned on, and it will try to suck down through all of those holes. All of those holes are not opened up. When this machine first arrives on site, none of them are opened up. You must actually drill through any of the holes you want the suction to go down through. You can see a few of them have a little yellow or a red stopper in them. Those yellow and red stoppers show holes that have previously been drilled through, which will now allow the suction and the compression to go down through those holes. But in this case, I want to plug them, because if I just want to sit something on top of these pods in a minute, I don't want suction and air escaping over there, so you're going to plug up all holes that aren't being used. It's probably bad practice in this case to drill out all the holes in the bed of the CNC. You just drill out the holes that you need and plug them when you don't need them. Now in this case I don't want to sit this on the bed of the CNC. I want to allow the cutter to go down and cut beneath the surface. So we can use these things. These are ones that are made on site, but these are pods. Now if you look carefully, there are two holes, one there to the right, one there to the left, and there's this little shallow groove. It's kind of in the shape of a cross or a H. And those two little grooves will go down into a hole that has suction going up through it. This rubber seal will make a very tight seal with the workpiece, so when the workpiece sits on top of it, the suction will come down through the hole there and suck the timber down tightly against that seal. And the good thing about those manufactured on site ones is if there's an accident or if they get damaged, you can simply replace them. And just in practical terms, if there's any little nick or groove in that rubber seal, it compromises the seal and the workpiece may move when the program has actually been processed. And you'll see that in a video in a couple of seconds. You'll see it actually being clicked into place. It's important to note that this corner where my mouse is now is not the origin of the machine. If I backtrack for a second, The origin of this machine is way back in there under the machine head. That is 0, 0 in this machine. That makes it a little complicated to actually set up and position the piece. You have to lift this hood and reach in under this dust guard and actually position the pieces at 0, 0. So in practical terms here, we always use this machine off this corner. So it's just a matter of offsetting the piece over the length of the bed, and the width of the bed should be the same anyway. So rather than starting at 0, 0, we just reverse it and we move the program a set distance, a known distance over to this corner. These little connectors, or these positioners I should say, if I go back for a second, you want to make sure that it's precisely located at the corner. I suppose the de facto 0, 0 is going to be this point at the corner. So we're going to put a couple of those pins into these holes at the side. You'll see that in the video as well. And when those positioning pins are put in temporarily, you can align the workpiece with those pins, then pull them out afterwards after the suction and the compression has been applied. Here's a couple of the pods just before they've actually been fully prepared. You can see the holes drilled through. This little pipe just allows the suction to get up. That pipe sits down into one of the existing holes, and you can see here there's a deep groove removed for this rubber seal. You can buy those lengths of rubber seal, and as they become damaged, you feed them back into there just to make sure you get a very tight seal around the pod. And it just lifts the workpiece off the workplane or off the bed of the CNC. Here's a similar system in operation on the other CNC. The bed this time is made out of aluminium, and this time you don't drill out all the holes. The holes are there with these stainless steel plugs that you remove and put back in with an Allen key as you want. Here are another pair of pods. They're very similar. You've got the little kind of H-shaped groove, you've got an opening there, and those pods will be positioned over one of those open holes. So one of those open holes would position under each of those pods, and the suction would come down through the pod and subsequently through this hole, and it would pull the piece of material down tightly against this rubber seal. In this case, we've got the three positioners fixed in place all the time, and there's a little pneumatic on those that will withdraw them and stick them back up as they're needed. Just on a side note, seeing as I was taking a picture of that other CNC, you'll see that the other machine, you're going to have to lift the hood and manually change the tools and the cutters with a spanner. But in this machine, you can have a number of them preloaded already. The machine will simply come over, pick up the tools automatically and change them. When you were looking at the NC code a while ago, it listed the time it took to process each operation, but it also listed the tool change time. A machine like this greatly reduces the time wasted changing tools. This is what I was talking about. You can see that the hood has been lifted up. There's a number of different heads. There's two main heads here in the center, and there's a couple of drilling heads. So you can see, if I zoom in on the next slide, there's a drill head over to the left that looks exactly like a typical drill chuck. And sorry, if I go back for a second, and these two other heads then can each hold their own cutter, and you just manually have to remove those with a spanner and put in essentially the router cutter. Now I've pushed up those little dust guards there. Those dust guards usually come down, and you usually can't see too much of what's actually being machined because the dust guards are obscuring the view. So here is something that we've drawn previously, and we've applied the machining for this previously. And when I went to the machine, there was already a job sitting on it, so I just ran that job. So it's not the exact job that we've previously drawn or been working on, but the operations and the machine actually working should still give you a good idea of how a job is sent to the CNC. So in the video you're watching now, you can actually see the little positioners being put in place and the material being applied and the compression being turned on. And if you'll forgive the shaky video, here you can see a job currently sitting on the CNC when I went there. So what's happening on screen is just that the job is being sent to Alpha Edit. And down at the bottom you can see they're about to click and open up Alpha Edit, where the coding will be displayed and checked. And in this case they're going to actually press Start, and the job has now been sent to the machine. So now the job has been sent to the machine, just press Go or press Execute, and the job will actually start processing whenever it runs through the code and, I suppose, calculates the machining required. So you can see here that when the job is actually completed, the machine will withdraw and return back to its place. And this isn't the component that we had drawn in Alphacam, as I said earlier. It was just one that was sitting on the machine, so I ran the job again. The compression is turned off and the piece is removed, and there you have your piece that you're after. So that just gives a window into what it requires to have Alphacam generate the NC code and have it sent to the machine ready for processing. And there's plenty of other stuff beyond the scope of this module, such as the maintenance and changing of the cutters that we're not going to get into, but at least we see the workflow from Alphacam right the way through to the physical production of the piece itself. So what I want to do now is just move over and give you an overview of what's required and the typical type of questions asked in the exam that you're going to have to sit towards the end of the module. So you can find this exam paper on Learn Online. There's a file right below the link to this video. It's called Sample Alphacam Exam, and in it you're going to be asked to do 2 questions. In this case, if I just go to the actual exam itself, you were asked to do 2 things. The first thing was to draw this chopping board, and the second thing was the phone stand, both of which are very familiar to us because we've done versions of them before. So we'll start with the chopping board just to give it a quick look. There's a few things in it that are new, not much. The new thing for the chopping board that we haven't covered is this engraving of text on the side. We've never done that yet, but you can see the actual drawing of the shape and machining the shape of the chopping board. We've done previously. The hole for the handle can either be machined out or it could be pocketed out, and the groove for the drainage is just the ball end cutter applied around in the shape of a rectangle with filleted edges. I've also asked you to download and apply the GMIT logo, and that logo is available on Learn Online as well, but if you remember, there's a few issues in it, such as the text and the use of splines that need to be dealt with. What we haven't covered, and the only thing you're missing I asked you to actually complete this, is to engrave some text on the end. So on Learn Online you'll also find a working drawing for that chopping board. What I'd like to do now is try to have a go at processing that. You'll be able to do everything, or should be able to do everything, up to the point where I've asked you to put on the engraving onto the side grain. So please have a go at that and rejoin the video when you think that you've done as much of that as you can. And I'll show you in the remainder of the video how to change the direction of the plane and actually process sideways to get something like this achieved. So to begin with, we'll go to geometry and start a rectangle beginning at 0, tab 0, enter, and going as far as, I think it's 210 by 297, so it's an A3 sheet of paper. So let's go 297, tab 210, and there we have that. And I can see that the curve is radius 140, so I'm going to go to arc, and it's the second option here. It's 2 points and a radius. I'm going to click the bottom and the top. I'm going to put in 140. And you can see, because I've picked them in that order, bottom, top, the curve goes outside. Had I picked them top, bottom, and then picked 140, you see the curve will go inside. So let's cancel that. I also want to fillet the corners, so let's go to, where's my fillet tool? It's in Edit, and it's fillet, a radius of 40, press OK, and I just want to fillet those 2, and fillet those 2, and I'll fillet those 2 afterwards actually. And our next job is to put the opening for the handle. So let's go to offset 20. I want to offset a line and an arc, and I do want to offset as geometry. So press OK and offset that curved component inside. And now I'm going to go to trim, all, finish, and I want to trim away those components there, leaving, just tap escape, leaving the shape of the handle like that. And if I put another fillet on, I actually have the 40 loaded, so I'll put the 40mm fillet onto those corners now, seeing as I have it, and call back up the fillet and put in a radius of 10mm. Press OK. I can now fillet the 2 sharp points of that handle and give me the shape of the handle that I'm after. And let me just see how I'm getting on there. Pretty good. So now I'm going to go to offset. I'm going to offset in, let me just check my drone, I think it's 20mm. It's actually 15mm, sorry. So I'm going to offset in 15mm, 1.5 from the edge. So I'm going to offset in that, and all those components. Now because I picked offset, line or arc, I'm going to have to do these manually, but it doesn't matter. And let's just see how those goes. Yeah, I won't actually be bringing in that edge, so I'll undo that. And I can see that line needs to go from top to bottom. Instead of bringing that in, actually what I'll do is just draw a line from the top to the bottom, and it should be easier. So because I've offset that in 15, my radius now won't actually be 40. It's going to be 25. So I'm going to go to Edit, I'm going to go to Fillet, size 25, and just put the fillet on like that and the fillet on like that, and I think we're good to go. So I'm not even going to bother setting up a piece of material now. I'm just going to go to Edit, I'm going to go to Join, All and Finish. I'm going to press Ctrl G to turn on the Ghost Tools, and I want this outer edge to cut on the outside, I want this pocket to be inside, and I want to leave that one to remain centered. So let's do that. Machine, Tool Directions. Outside is going to be this outer profile. The Ghost Tool now jumps outside. Inside is going to be this pocket for the handle. That jumps inside, and I'm going to leave that one be. So close. And I suppose just actually for visualization purposes, I will go to 3D Set Materials. And do I have a depth of the chopping board? I do. It's 25. So 3D Set Materials. I better draw a rectangle actually temporarily. I'll just kind of guess it by eye for now. Press OK, and I'm going to select that as the material. 3D Set Materials. Click the rectangle. Top is 0. The bottom is going to be minus 25. So go to an isometric view, and you can see the block we have to work with. So there shouldn't really be anything new about processing the outer profile. So let's quickly do that with a 10mm cutter. Machine, Select Tool, a flat 10mm, and let's go to Rougher Finish. The safe rapid level will be 40, rapid down to 5, material top is 0, and let's go all the way through, minus 25, and let's say it's going to take 3 cuts. So press OK, and select that outer geometry, and press Finish. Now let's do the pocketing exercise. So pocketing, I want to use the same tool, the 10mm cutter will be fine. Levels and cuts will be okay. Everything should be fine there. So still leave it at 3 cuts. If this was a hardwood, you might even go 4 or 5 cuts, but 3 cuts is fine. For now, press OK. Select this pocket and press Finish. And you can see the pocketing exercise will now remove all the material from the handle. And the last thing we've left to do then is go to Rougher Finish. I'm going to go to General and change the tool because I want, let me just double check the drawing. It's a 15mm offset from the edge, and it's a radius 10mm cutter to a depth of 2.5. So let's get a ball end 10mm cutter, that'll work, and the levels and cuts will be 2.5, so minus 2.5. So 1 cut is fine. I don't need 3 cuts to go down a small bit like that, so a single cut will work. So press OK, and select that groove on the inside and press Finish. So I'm hoping now if I go to run the simulation and press play, that's too fast, I'll run it again, press play, it's going to cut out the shape of the board for me, it's going to get in now and cut out and pocket the handle for me, and it's going to cut out the groove like that, which works. One thing I actually forgot to do is let's just put on a groove or a chamfer around the edge, or you could put on a bullnose cutter if you have one. I don't think there's one loaded into this version of the software, so I'll go to View, XY, and I want to run another cutter along that green line and that green line, so I must change the tool direction. Machine, Tool Direction, Center. So I'm going to center that green ghost tool down here at the bottom, and this ghost tool over here for the handle, and press Close. If I go to my operations, you can see that there's 2 asterisks there, and 2 of them are blue, which shows me that there's an update there if I wish. If I right click and update this finish pass, then this existing toolpath, the blue one, will jump onto the middle of the line, but I don't want that. I want to go and select a tool now. I'm going to use the 45-degree VGC V-groove cutter. And let's go to isometric. And I'm going to apply that rougher finish along the center line, the center of that outer line. So rougher finish. The only difference I want to make here is I don't want a final depth of, I certainly don't want more than 1 cut. A final depth of minus 2.5 actually might work, so I'll leave that be. So press OK, select this outer line and select that kind of edge of the handle and press Finish. And hopefully now with the simulation, the last operation will run the V-groove cutter and put a chamfer on those edges. Now, how would you put the chamfer on the bottom of the board? You'd have to turn the board over and process another operation to put the bull nose or to put that chamfer on the bottom of the board as well. So I'm going to stop that simulation in a second, but there's a little issue here in that I've left an awful lot of material around the edge. If I now want to come in and engrave from the side, I need to get rid of that some way. So I might actually just tidy up my drawing a little bit. So let's go to Edit, Delete, and I'm going to delete that outer block and press Finish. Delete one geometry. Yes, don't worry, it's not going to get rid of any of the toolpaths or the geometries that we drew already. So if I go to view and then XY, I just want to put on another fresh rectangle. So let's go to geometry, rectangle, and I'm going to put this on a little tighter. So the bottom left corner is going to be -5, tab -5, enter. And the upper corner there is going to be, let's say 355, tab 220, okay. And now if I go to 3D set materials and set materials there, view ISO, and if I run the simulation, you can see I now have clear access to get in there and engrave the edge of this board. So I'll press stop there. Now, I've already gone over in a previous video how to import the GMIT logo and how to troubleshoot it, so I'm not going to waste time by going over that again. You can see that it was required that you bring in the logo and actually engrave it onto the face of that. So please do that in your own time as well. So to actually get and write on the words dishwasher safe on the edge of this, what you need to do is turn the cutter, because if I go to machine, select tool, and pick the engraver, which is what I'm going to use, sorry, that's the wrong one. I'll just pick the user engraver. There it is. There's no way I could engrave text on the side grain of that with the cutter going in that direction. And you'll notice the cutter is pointing up and down, the engraver. It always goes and follows the Z direction, because the Z direction is the direction of the machine's up and down axis. So tap escape. What I'm going to do is go to this work planes tab. And we'll work through a few of these as we progress through the module, but the one I'm after today is this one. It's the most useful one. Slice through work volume. So click that, and it's a little subtle because it just highlights the plane ever so slightly. And you can't pick that edge plane by anywhere in its middle. You have to select it by its edge. And when you select the edge, the whole model becomes grayed out. The existing XYZ triad, the arrows, become grayed out, and I get a new yellow temporary or local triad. Now, it's important that that yellow Z is pointing away from the surface, because if I go to machine now and select tool and pick up the user engraver, you can see now it's going to point the correct direction and I can draw and machine on the edge. If that Z were in the wrong direction, you can always go and flip it. So go to work planes and you can go reverse current plane. And when you press reverse current plane, you see there's a number of different versions of directions of that. So if I just make the mistake here, reverse current plane, I can see the Z is pointing away from the workpiece, or rather into the workpiece. Now if I go and select tool, you can see what will happen is to engrave the text here, the cutter is going to come from the far side, mill its way through all the material and then start writing on the end grain. So make sure that you put in the plane, but that you use reverse current plane to make sure that the Z is pointing away from the workpiece. So reverse current plane. What I'm going to do now is go to machines, select tool, select the user engraver, and just leave that there. And now if I go to geometry, and let's put in some text, say, and I'm okay with that, just press OK. Now the plane that I'm drawing on is actually this plane, and my X is there, my 0 is there rather, and my Y is there. So I'm just going to start randomly over here in the center. I'm going to type in dishwasher safe and press OK, and press escape rather than OK. And because that is yellow, I know that's text, so I'm going to go to edit, I'm going to go to change from text to geometry, select the text and press finish. You've got the ghost tools there, I don't really need those. Now I can go to machine, a rougher finish, levels and cuts, we can leave all that the same, but the final depth here is probably just going to be -1 mil. See how that looks. Press OK, and I'm going to select all of that green text. I missed the E there, so I'll just press that as well. In fact, I'll just undo that because I missed the E, so I'll just do it again very quickly. Rougher finish, OK, I'll just select all of the text this time. There we have it, and press finish. So now, if I run the simulation, I'll slow it down a little this time. You can see all the operations will work as we expected them to. I'll pause it there for a second because there's no excess material here. The cutter doesn't have any extra work to do milling through it to get that yellow surface to engrave the text. So it's going to put on that now, and here it should get in and engrave the text. Now, I made a small silly mistake there myself. I'm after realizing that because I sliced through the work volume there at the edge, it's only cutting below the depth of that grey face. It's not cutting there. So you have a couple of things you can do. You can either go back and edit the block itself. I'll stop the simulation. or I know I've come down -5 mil, so I'm going to edit that operation. So my finish pass, right click, edit. I know that I've removed 5 mil material, and now I want it to go down another mil, so I'll actually just change that to -6. Or there's nothing to say you couldn't have had the block the exact shape of the chopping board. So let me just have another go at that simulation. So press play again. I'm confident that'll work this time. So now it starts engraving into the side, and it does. So if I stop that, it's still in this local side grain orientation. That yellow triad is still there. So if I now want to write something up on the top again or edit another plane, I can't do that. I need to go to work planes and cancel work plane. Likewise, if I wanted to draw on the end grain of the piece here, I'd select slice through work volume and select that side or the back or any other plane indeed. But you always have to get back in then and go cancel work plane, and there you have it. The last thing I actually asked in that exam was to have 5 of the boards available for machining. So the correct thing to do at this point would be to just go to edit, go to delete and delete that block, press finish, go to view and ISO, not ISO rather, XY, and copy or pattern or array that another 4 times. So go to edit and go to array. I want to array everything in that box and press finish. I want to bring both the toolpaths and the geometry, so both. And I want tool sorting. I want it to intelligently tell me what's the best and most efficient way to machine all of them together. The number in the X direction will be 5. The displacement will be, let's say, 350. The number in the Y will be 1, and there'll be no displacement. So press OK. And I just need to put a slightly bigger value in there. So let's try that again. Let's put in 375 this time. Press OK, and there we have it. So now there's the 5 boards, and I can now determine that the piece of timber I need to actually process those is going to be -5 tab -5 enter, and I can kind of guess this if I want there, but I won't. I'll put in 185 tab 225. That should actually be 1850. 1850, and then the Y is 225, so press OK. So now if I just go to 3D, set materials, press OK, view, ISO, I now have 5 chopping boards. And if I run the simulation, that's the last thing we'll do. It does it in a very efficient manner. It's not going to just do, let me just double check something there, because I see that it didn't actually copy that operation. Yeah, it didn't actually copy the dishwasher safe operation, so I'm going to stop the simulation and I'm going to back up until I just get rid of the pattern, and I'm back to the situation where I just have my block like that. So if I'm not mistaken, there's a couple of different solutions to this. I'm after deleting the block. Let me just quickly draw on a block again. So go to view, XY, geometry, rectangle, and let's start at -5 tab -5 enter, and I'll just pick that one by eye. So 3D set materials. Okay, now I think this has something to do with the 2 planes we've used, so we'll experiment. So if I go to go to edit and go to array, if I select all and finish, it seems that it's only going to bring all of the operations on that single plane. So if I go to work planes, slice through work volume, and go back to this plane, now while I'm in this plane, if I go to array, select all and finish, and pick all the same operations as before, you see, yeah, now it does bring that. So in this case, using the array, you need to bring the array on one plane and array the other plane. But I think there's an easier way to do it. Let me try that. So go to work planes and cancel work plane. So what I want to do is bring everything with it. So I'll actually just get rid of that block again now. Edit, delete the block, finish. Now what we'll do is, instead of using the array, I'm going to use the repeat. Now the repeat, it asks me to select everything, so I'm going to go all and finish. It selects everything. I want to array both. It asks me to pick up a start point. Remember now that this is in the XYZ. This is 3D. It's no longer just X and Y, it's XYZ. So I'm going to start at 0, 0, 0. So press OK. So in fact, it's going to pick up 0, 0. It's going to ask me for the displacement. So I don't want Any displacement in the Z, I don't want any displacement in the Y, I just want displacement in the X. So the displacement I want in the X is 375. So press OK. How many do I want including the original? I want 5 of them. Press OK, and it gives me 5 of them, but it brings everything. So perhaps the repeat command might be better in this case when you want to get a copy or a pattern of machining and operations on multiple different planes. So now if I go to geometry, we're getting there. And if I go to XY, and I draw my rectangle now starting here, let's say at -5, tab -5, enter. And let's just see something that'll work here. Let's say 1850, tab 220, enter. So 3D, set materials. Let's go to an isometric view, and hopefully now the simulation will run fully from start to finish and put in all engravings on all boards, and it does. So there you have it. Now I know what you're saying, if we don't have the machine with the capability to do this side engraving, then you can't actually do this. I know the machine we have does not have that capability, but the software certainly does. So at this point in the module, you should really be in a position to complete this first portion of that exam, question 1. What we're going to move on to next week will be, or maybe the next couple of weeks, will be all of the things that are left in order for you to complete this exam. And the only thing that's missing, if I move over to the work and drawn for this phone stand, we've already pocketed out the phone, we've already put the spline on, but what we've not done so far is actually create our own custom tooling to generate a very precise type of groove or profile. And we'll do that in the coming weeks. So thanks for listening, and we've completed those exercises, the chopping board mainly. Please save it and upload it to the designated slot on Learn Online before the upload closes.